Hungarian American architect. I moved to San Francisco about 20 years ago. And tonight I will talk to you about architecture and technology in architecture. So the combination of these two might be interesting and might be different than what you typically hear about architecture. And it also gives me a great opportunity to clarify myself, because I often find myself in a particularly convoluted situation when I talk to my friends and family, and when they ask me what I do. I deal with data, but I'm an architect too. So the two of them are just weird to come together. So hopefully tonight and preparing for this presentation gives me an opportunity to make it clear for myself and everybody else too. So after this brief introduction, I would just use these slides in the background. Architecture has really changed quite a bit from early beginnings, and as you saw it in the invitation, from all the way from mud buildings, mud brick buildings to today's skyscrapers, and technology has played a great role all the way through. In particular, tonight we will highlight one recent technology, which is called building information modeling. And if you haven't heard about it, then tonight might be the chance to learn a little bit more about what building information modeling, or BIM, is about. I'm an architect and also a BIM specialist, and that is very significant to me because I have almost inherited this specialty just because I'm Hungarian, and I will reference that as well later on in the presentation. So let's start with the evolution of architecture. I have meeting notes, and for the format, I was thinking that we could just treat this as a casual conversation. I can go deeper, or I can stay high level, depending on what your interests are. And Zoli, I think that you might be able to help me with the questions if they come up online as well. So we can talk about a lot, and we can go very deep in every subject, but I will try to stay high level conceptually so that we can all follow what's happening. So let's talk about the evolution of architecture itself, and that gives me an opportunity to introduce where innovation and where technology was playing a crucial role. If we go back to the Industrial Revolution, that was, let's just start there. That was a significant change in architecture because materials and certain techniques introduced vastly different constructions and vastly different buildings when that happened. New types of material that were stronger than that was used before in history introduced taller, skinnier buildings. So here, think about iron and think about the Eiffel Tower. That was a huge change in architecture, and that was brought about by technology and the change of technology, and also through structural engineering innovation too. Architecture, of course, is a form of engineering, and there's a lot of interconnectedness with other disciplines too, as we will talk about this. Now let's jump straight ahead to the digital era, and let's talk about what is called, even today, computer-aided design. This technique and this technology is vastly used in many different industries, and architecture is no exception from that. We've had wonderful presentations about aspects of how computer-aided design can be used in different industries as well here at the Innovators Club. And in architecture, it brought about a major change where from drafting by hand, people could move to the computer and rapidly make changes to the drawings, rapidly copy the drawings, which was before a very tedious process. Out of computer-aided design grew building information modeling. Some might argue that it's a form of computer-aided design, but the major difference is that while with traditional computer-aided design, we typically talk about two-dimensional drawings and two-dimensional elements in the computer, building information modeling brought about three-dimensional aspects of buildings in the computer. So architects started to create 3D models of computers or virtual buildings in the computer, as we will dig into that in many different ways. So moving forward, there's still a couple of milestones and phases in history as we get closer and closer to today's date. And the next one that's worth highlighting is sustainable architecture. Although architecture was always about being in harmony with the environment and making spaces and places that are not just pleasant for the occupants, for people, but also merge into their environment well, sustainable architecture in particular started to focus on materials that are not just durable, but also harvested and created in a way that is good for nature, and energy usage by the buildings. So this might be a good point to mention that why are we even dealing about this? Why do we talk about architecture and technology? Does it have to be evolving? Does it have to be combined with technology? People have been doing architecture for literally thousands of years in many different shapes or forms. So what's the big deal? Well, for me personally, one of the biggest key performance indicators of why I'm pushing myself in my field is that today buildings represent 30% of the energies world use. 30%. This, of course, includes the construction of buildings, the materials that are created. Concrete produces a lot of CO2, which not a lot of people know about. So if we can make a slight change and make things more efficient, then we can do a lot of good with technology moving forward. And that's what sustainable architecture is.
A question from online. They are asking with CAD, how much are people following the old workflows versus using the capabilities of the new tool?
Yeah, that's a good question. So we will talk about that a little bit more in one of the following slides, but generally speaking, the way architecture is created is still traditional. You still need to start with a concept. You still need to imagine what a good environment, what a good space would be good for a particular purpose. And you still need to create drawings. It's how we create it and how many iterations we can do and how integrated we can make the process is what's changing. Hopefully that answers, at least for now, that question. So going back to sustainable architecture, it's also a good reference to this building because Eva and I was just talking about this. This is not a new building. What is the age?
50 years old.
50 years old.
50, it's pretty revolutionary,
Yeah.
I think.
Yes, I agree. And you could also see the placard out there that says LEED Gold, which is leadership in environmental engineering and design. And that's a certification. That's a sustainable architectural certification that this old building even acquired after, of course, it was built, because the energy used, the materiality that's used here makes it able to acquire this title. So that's what sustainable architecture and the whole certification around it is all about. Then let's move even further in time in history. We're still talking about the history and the evolution of architecture and technology. And let's talk about smart technology. So here you may have heard about IoT, or the Internet of Things. That's a big deal. And that's a very recent thing that got introduced to architecture and buildings recently. These are sensors and controllers that are placed all over the building and makes our buildings much more responsive and much more able to create a space or create a changing environment that's appropriate for the use. Data-driven design is also another thing that we will get into a little bit more. What that means is that we can now, thanks to these technologies and largely thanks to building information modeling, gather data, the underlying drivers of why we design things or why that building is going to perform, especially in terms of sustainability in a certain way that we would like. And then let's now jump toward the future. So things that we're looking into now, not quite mainstream yet, are some futuristic concepts like parametric design. It's been around for quite a long time, and you will see that actually the word dates back to the 60s. But even today, people and architects are still experimenting. It's not widely adopted yet. Parametric design is all about creating designs in the computer and then changing certain parameters to change that design. So imagine a virtual lever that you can use to turn the building 5 degrees toward the south. How does the energy use of the overall building work that way? Or if we turn it backwards or create a different shape, what does that make in terms of changes and the concept? 3D printing is a very interesting thing, and not the way you might imagine it, because yes, of course, 3D printing is used to create small scale models to imagine what that future building might look like. But today people are building buildings with large 3D printers, and that's a very promising technology where we can create sustainable buildings rapidly, much faster, of course, than normal construction can bring this about. So let's move on to the next part. Unless you have questions, I will pause at every slide if you have any thoughts. Otherwise, we will just keep going and we can discuss the rest of it. So let's talk about the definition a little bit and the significance of building information modeling itself. So we will dive in deep at this point. I will read this out, but I do think that it's a fitting definition. A digital representation of the physical and functional characteristics of a building or a project or an industrial project. That's what building information modeling is all about. So one more time, the digital representation of the physical characteristics and the functional characteristics of a building. This describes the building of what it will look like, but it also describes how the building will function or how it will behave in certain scenarios. And the significance. So let's talk about the significance of it. Here we can start to talk about certain concepts. So let's talk about multidisciplinary design. Bear with me because I will introduce probably new terms and new ideas here. But we already referred to this. So I mentioned before that architecture is a form of engineering, and architects collaborate with other types of engineers in designing and preparing the construction of buildings. Mechanical engineering that design the mechanical systems of a building are significant as collaborators to architects. Electrical engineering, all of the electrical wiring and all of the systems, and many other disciplines are involved in creating a good building today. Multidisciplinary design is all about coordinating their work. So imagine that way back when, the way architects and engineers collaborated was that architects drew a drawing and they handed it over to an engineer, a discipline engineer. They created an overlay. They used to have light tables where they literally overlaid drawings on top of each other in layers so that they can see how the impact is and how the two systems are correlating with each other. Well, today, and even decades ago, we were able to introduce CAD in the computer where we could, as you can imagine, much more efficiently overlay these different systems and coordinate them much better. But now with building information modeling, we can do this all in 3D. That's yet another huge advancement that we can take advantage of. Well, the efficiency of design and the design analysis has benefited from BIM too, and that is a significant piece of why BIM is so important to us today. What I mean by this is that while if you can imagine one could draw a sketch or a floor plan, there's only a limited number of variations that an architect could explore way back when. So it really happened up here. They needed to think about it, they needed to conceptualize it, they needed to imagine different scenarios and model it in their heads. Today, we can do this all in the computer. So we can create 15 different variations of it. And that's significant because we can this way find an even more optimized version of the future building. The more we can invest in versions and changes and variations up front, the better off the whole process is, because once we get to the point of being out on the site and building the building, everything is much more expensive and everything is pretty much set in stone at that point already. So the more we can iterate upfront, the closer we're going to get to an optimal outcome at the end. Okay, so decision making, as you can imagine, is a critical part of architectural design all the way through the process. And decision making has to be built on input. It has to be built on data. It has to be built on sketches, variations. So data-driven decision making is very much advanced and enhanced through building information modeling, because these models can provide the decision makers the building owners or the leaders in their disciplines with the right information. And then finally, change management is a big deal. This is not just typical to architecture, but other industries too. So how we make changes and how we make those iterations and keeping track of which one the latest version is that applies to everybody else is a big deal, especially when you deal with 10 or 15 disciplines in large projects sometimes. 15 disciplines, and then each discipline might have a team of 30 people, let's say. So you can imagine that they produce lots of variations, and it's important to stay absolutely on top of what is the latest and greatest that dominates and that dictates the next steps. Okay, so this was a little deep dive into the significance of BIM and what this is all about. We will do other little deep dives here, but let's now proceed with discussing a little bit the history. And I found this image, which I thought was very fitting for the slide. You probably don't recognize the people in here, but I will talk about it. You do, Eva? Yes.
Gabor?
Yes. Gabor Boya. That's right. That's right.
Yeah. I know. He used to have an office there. So yes.
Yeah. So the reason I'm really excited about talking about technology and building information modeling and architecture in the context of the Hungarian Innovators Club, and I did mention to you that by the virtue of being Hungarian, studying in Hungary, I got my master's degree in architecture in Hungary. I de facto became a building information modeling expert because we grew up with this technology even before it was called building information modeling. And this is partly because of the pioneering contributions of people like Gabor Bolyár, who is the founder of a company called Graphisoft in Hungary. And Graphisoft produces a software called ArchiCAD. And believe it or not, he started this and introduced ArchiCAD in 1987. And it was already a three-dimensional virtual building software that had a database behind it, and each element of the building had information, metadata, attributes assigned to it. So you could query it, you could rapidly visualize the buildings. That was unheard of at that point yet. Of course, there were other explorations before. So this goes all the way back to actually the 60s. So let's talk about even deeper histories here before Gabor Bolyár. So this whole thing about parametric modeling goes back to really the 60s, which is essentially having data about changing values, putting together a model where you can change the values and that changes certain characteristics of a model and certain behavior of the model. That applied to many different fields, and architecture was exploring that as well. In addition, graphical user interfaces was a big deal back in the 70s. So especially for a domain or a discipline like architecture, you can imagine that was a critical next step in the process that led us to today. And then ultimately, this whole building information modeling and the concept of it was gradually introduced, starting arguably with ArchiCAD back in 87, when it wasn't even called BIM, it was called virtual building. And then in the 90s, it started to propagate and become more mainstream. And I have to say that we here in the United States do something really well, which is marketing and market infusion with certain ideas. So here comes Autodesk, a competitor to Graphisoft. And they purchased a back then budding little company that produced a similar program called Revit, which is the equivalent of ArchiCAD. And Autodesk did a fantastic job distributing this idea and this concept around the world. So if today you speak here about BIM, it's very rare that you find people that will associate it with ArchiCAD. But that's just the way how things are. We Hungarians sometimes are way too early to the market too, which I think is arguably the case with ArchiCAD too in many ways. But don't worry, ArchiCAD has its fair share. So in Asia and other places in the world, it's very popular today and a significant and dominant player in the building information modeling world. So I'm just looking at some of my notes because I can really dig in deep into all of this subject. But this is pretty much covering what led us here and how building information modeling came about. So let's now talk about collaboration itself. We did already mention multidisciplinary coordination, but let's talk about it in more practical terms next. So multidisciplinary coordination maybe they started with light tables, but today I mentioned that we can do it much more efficiently with the computer. We don't stop there. There's a whole revolution around building information modeling and the current advancement. So imagine that the building information model in the computer is this virtual common data environment. It's actually referred to as the common data environment in Europe and other places too, where all of the disciplines can contribute to, extract information, get the latest and greatest, but also contribute their own changes and their own innovation and design. And it actually happens real time. So we're doing this in the cloud. So project teams can collaborate across the world. That's a huge change. So if Frank Geary wants to design a new building in Kuala Lumpur, his associates could stay in the United States or wherever they are in their office, and the local architect in Kuala Lumpur can ensure that the local regulations are applied to the building design. And this is all happening real time. What's even more, we can take advantage of different time zones. So often we collaborate with our team members, knowingly taking advantage of when it's evening here, then the next day starts at that point, so we can hand over the latest design iteration on architecture, so that the engineers, the mechanical and electrical engineers, can start to make the changes accordingly, how the building shape is forming and changing over time. So this is, you can imagine, absolutely significant. I also already mentioned the design options, how the design options can rapidly be cycled in earlier on, and we can really optimize through the sheer number of hundreds of changes, which are possible because of the new technology. But imagine that it's not just the project team who benefits from this, but also the customer, the client, the stakeholder, who's going to be the future occupant of the building. I've spent quite a lot of time designing healthcare facilities, and you can imagine there that we have lots of future customers that we need to make sure are satisfied with the future building. I remember in our case with the UCSF medical office building, we had 400 customer meetings just with the nurses of the future building, 400, to make sure that everybody gets their needs met through the future design. And this is possible because we can do rapid iterations, we can visualize these concepts to the customers, which is a brand new thing. Way back when, architects used their hands and created wonderful, beautiful hand drawings and watercolors, but it was limited in terms of how many one could do in a certain amount of time. We will talk a little bit deeper even about this, of how this collaboration and visualization can help the whole process in one of the next slides.
A question about the iterative and changing design. Somebody's asking if there is any automation for routing of electrical or water lines or similar for some change in design.
Yes. And that is driven by artificial intelligence too these days, which is just a form of machine learning. But yeah, let's not get entangled with that subject. I'm sure that there will be a future presentation about just that. But yes, we can make use of the computer and the data-driven design. And we could say that here's this complex building. So imagine just the ceiling, and imagine that I want to route this HDMI cable in a way that's least visible and not tangled. So I can ask the computer with certain advanced programs now to route it in a way that's getting tucked in all of the corners in the most optimal way, minimizing the length of the cable, because of course I cannot go too far, because then the data is dissipating over a longer cable. So all of these competing factors can be just programmed in and it comes out. But here too, we're not the only industry who benefit. from these kind of advancements in technology, but we certainly do, and we certainly appreciate it. Okay, so let's move on. And by the way, there's a reference here which I wanted to point out. So the architectural industry, or the AECO industry, or sometimes called the AEC industry, more typically, which is architecture, engineering, and construction. These days, I like to refer to it as the AECO industry for one particular reason in the context of our presentation or discussion. And that is that BIM and building information modeling first got introduced through people and companies and software like ArchiCAD to architects. It helped because before that, architects needed to draw building drawings, elevations, sections, and floor plans independent of each other in CAD. When building information came about, it created the ability to model the building itself, the virtual model, the 3D model. So imagine that for a moment, instead of drawing a window on the floor plan view and on the elevation view and the section view, 3 independent drawings, which all need to be coordinated, because if I move that window 5 foot over because of certain changes in the design, then I have to change it 3 times. And I want to make sure that it changes exactly the same way in all of those drawings. With building information modeling, I can grab that element, that 3D object, which is the window, push it over by 5 feet, and the drawings become representations, so sections or views of the 3D model. So it automatically happens. That's huge. That's huge. But then the construction industry got a hold of it, and arguably they did a much better job in benefiting from or maximizing the potential of it from the financial perspective. And that's because construction is really costly if you don't prepare for it well. If you find issues on site, that can delay things by weeks, then the workers are holding still. Large element and equipment are being rented for a lot of money, and they cannot operate according to the plan because they need to resolve an issue. So what the construction industry did was that they came up with the pre-construction coordination, and we will talk about this a little bit too, clash detection, clashing different elements in the computer upfront, different systems upfront, and really finding the right way to build that building, not just to design that building, simulating how that building is going to be built so that they can find the problems and the issues upfront, solve those things, and then make the construction much smoother. So there's the AE, architecture, engineering, and C, construction part. And now finally, and this is the big promise, the building owners, the customers started to play along too. I happen to work today for a building owner representing all of this in architecture, because finally the world is ready for that. And building owners realize that if they actively play part in it and actively lean in, integrating themselves with the technology, they can benefit from it tremendously. And this is because a rough rule of thumb, which is that if you do BIM well, you can save $1 in design, you can save $10 in construction, and you can save $100 through the operation, through the life of the building. So you can imagine that that's also a really, really big deal. That's why it's AECO, not just AEC anymore. So let's move to the next one. And let's talk about sophistication and efficiency. So this is going back and diving deeper into all of those design options and how we can do things. But let's take a moment to talk about some other aspects that building information modeling can bring about too. And this has to do a lot with visualization to begin with. I spent my early years of my career, as all of us do when we were younger in architecture, creating wonderful, beautiful, artistic visualizations and renderings, which used to be done by hand before, but we could do it from this angle and that angle. I actually used a program that I was absolutely fascinated by, which is essentially virtual photography. So I could not just create the model, but put it in a space and imagine that there's a virtual camera looking at it, and I can adjust the shutter speed and the aperture size and it calculated the bouncing of the virtual photons, simulated it, but close enough. That created a much more realistic, much more photo style image of the building. And people loved it because it made them able to imagine what that building will look like in the future. Both architects, designers, and the owners as well, as you can imagine. Virtual reality. So that's a thing in architecture too. And that is only possible because we have now the 3D models that we can put into virtual environments. So now we can give our customers the opportunity to literally put on a goggle and walk around and see what the future of the building would look like, or a change in the building would look like. That's a big deal too. Design optimization and performance. Of course, we talked about it, data-driven, multiple iterations, testing out if we change a little this parameter or that parameter, what will it mean for the future of the building? I want to pause here in this deep dive and talk a little bit about energy modeling. I have been fortunate enough to work with some of the best, for example, with the Lawrence Berkeley National Laboratories and other places that are deep into this subject and really leaders in this world. And the reason is because we were getting really good at modeling the physical building and some parameters like the cost of this brick. So I can calculate that if I have 500 square feet of this brick, then it just spits out the number. I don't have to do hard calculations and all sorts of things. But then energy modeling came about too. And I remember that our company was acquired by a larger company. And with that larger company, there was a group, a dedicated energy modeler group that came on board. And I found a brand new friend, my equivalent. I was leading the BIM innovation in the company, as well as being an architect, a traditional architect designer. And then he was the energy modeling guy. And then we were talking and we were saying that, okay, now that our companies are together, you have the architectural building model, I have the energy model. Why don't we just push a button and then marry the two, and then we can calculate quickly how it is? Well, we were absolutely astounded that we couldn't do it. It just didn't work that way. And it's because energy modeling is vastly more complicated and computation heavy compared to anything else in my industry that I know about. Calculating how the air will flow and change, how temperature in the materials, depending on their physical properties, will impact the environment is enormously complex. So when you, and here too, we've had very similar, interesting presentations in different disciplines about this. But you can imagine that if it's about a building, how this atrium here is going to serve the occupants and create a comfortable environment is based on a lot of complex parameters and a lot of complex things that are super hard to calculate. So what ends up happening today is that there's a lot of approximations or a lot of assumptions embedded in those models. And that's why you can't just push a button and take a physical model of a building and shove it into an energy modeling software, because the energy modeler has to make those keen calculations and approximations so that it will be even possible to calculate. In the future, and I'm really excited about this, even though they say that it's always 5 years away, quantum computing can change this, because quantum computing can really bring about the speed where we can just brute force the system and calculate it, but not quite today. Not quite today. So we talked about parametric design explorations, some energy modeling.
There's a question
Yes.
online about the sophistication, that whether there is any example of a beam being used post-construction, whether the building can know the current inhabitants to try to set controls to their individual tastes, like temperature, light, sound levels, colors, or whatever else.
Yes. Thank you for whoever asks these questions. Really well presented questions. Yes, there are examples of this. So I also happen to be able to work with NREL, the National Renewable Energy Laboratories in Golden, Colorado, and they're famous for advancements and leading the industry and leading the way by clear example about what's called net zero energy buildings. And what that is that they design buildings so efficiently that the net energy use of the building over a whole year is zeroing out. Now we can do even better today. Buildings can not easily, it's very much possible that we can build buildings that can produce more energy than what they consume. But even just getting to net zero is an important thing because of the KPI that I mentioned earlier, that buildings consume 30% of the energy in the world used today.
Is this called a green building?
Yes, that's connected to green buildings, very much so, yes. It's a specialized, more extreme form of green buildings, the net zero energy buildings. So NREL is leading the way because they're innovating. They're doing crazy things like creating artificial lighting in lab environments just to test out how that energy can be harvested and other things too. I had a chance to visit them, and it was really fantastic. And there was a collaboration between my company and the energy modelers of my company and NREL to design a prototype or demonstration office building that they actually used on site in Golden, Colorado, which was, of course, a net zero building. Now, that building has a big interface, a tablet in the lobby, which everybody can interact with, that shows the current usage of energy of the building. And it has a system, a smart system all across the building, where occupants can signal that, hey, I'm too hot, I want to do something, and then the building will change accordingly. Or you can, as a building facility manager, look at the system and spot that, hey, this part of the building is too hot in the summer, what's going on there? And sure enough, the window was left open, so the building cannot cool down and cool itself down optimally. These things are very much possible, and these kind of collaborations between human and the system is really beneficial. So we were talking about all of the sophistication and the efficiency. Construction sequencing is another sophistication that was brought about by 3D models and building information modeling. Sometimes they refer to 2D, 3D, and then 4D, and then 5D. The 4D part is the time factor, and that's heavily used in construction. More advanced construction companies can do animation and sequencing in the computer, where you take a big prefabricated element of a bridge and you can simulate the exact sequence of how they can be brought to the site with a big truck, how they could be lifted in place, and so on and so forth, really testing it out ahead of time to avoid all sorts of complications that are costly on site. 5D is referred to the money factor in all of that. So we can simulate how costly the building is. If we change this material, what does that mean? Of course, you can imagine that there are lots of variables here that we're talking about, because that material should be sustainable, durable, and cost efficient as well. So all of these factors can be calculated now, and different variants can be pushed through the system. So sustainable design and the materiality is a big deal in terms of the sophistication that building information modeling can support. And then let's talk about some specific examples here, because that might be easier to see. I collected two, one from the United States, the One World Trade Center, which is also known as the Freedom Tower, which was built on the site of the original World Trade Center. Here, BIM was used for complex design visualization. It allowed the architects and the engineers to create detailed 3D models of the tower, including its intricate geometric design and unique stripes that are characteristic of that building. It also, of course, helped with the interdisciplinary coordination. It facilitated collaboration between multiple disciplines, and also helped the structural engineers and the MEP engineers and the facade engineers to coordinate really keenly with each other. They did use, as many other large projects used, what I mentioned previously, clash detection. So they clashed these systems virtually before they went out and built them. And you can find a lot of hidden problems this way. You wouldn't imagine. I mean, hundreds of these clashes appear. And we're talking about the most sophisticated and advanced designers, but the human brain is just not capable of imagining all of that complexity up front. So it helps a lot. Another example is from London, from the UK, and it's called the Shard. which is a stunning 95-story skyscraper in the center of London. And it's in an iconic glass-clad pyramid design. And they used BIM for optimizing and visualizing the design. And it's played a crucial role in the complex, in designing the complex geometric shapes. How are we doing with time? Because I'm not really watching it.
41 minutes.
Okay. All right, thank you. So I want to do another deep dive. And this is about integration and data management and visualization tools, but we did talk a lot about it already. So we will touch on a few new things. Data-rich elements. So you can imagine that these elements that made up the 3D model have almost their own life. They have their own attributes, they have their own properties. Often they are provided by the product vendor themselves. So many product vendors become sophisticated and offer 3D component libraries on their websites that the architects and the engineers can just grab and plug in and visualize what the actual product is about, not just because of its size and view and visual characteristics, but also performance characteristics. MEP models, mechanical, electrical, and plumbing models in the computer can really simulate the functionality. So they make calculations based on those models, how the pipes should change in terms of size and all sorts of other things too. We did talk about already, of course, the realistic visualization, animations and walkthroughs, simulations, 4D and 5D. I jumped ahead and I talked to you a little bit about it. So lots of things about integrating the different disciplines and integrating the data that's backing what we do in design is all possible because of this complex platform and technology that we're using today. Okay, so next I want to mention a little bit more about my personal experience, just to put it in realistic context. I already talked to you about the UCSF Mission Bay Hospital Center and Complex, which was a fantastic project that I was happy to participate in my career. This is a hospital, cancer center, and a children's clinic in one big building complex. And today there are robots in the building that walk around the people, the occupants of the building, that carry medication to the hospital rooms, to the patient rooms. And if the occupants in the elevator don't push a button, then they wait a little bit and they go ahead and push the button where they want to go. So really, really cool stuff. We did a lot of visualization here. We did a lot of complex simulation of what the building would look like and how it could function. We even needed to consider what the impact will be to the local community. Because you can imagine if you put a huge building complex in there, you need to consider how the helicopter comes in and carries in emergency patients and how that noise will impact the environment. We can do simulations about it. We can shape the building so it will be least disruptive to the residential occupants of that environment. That is possible too, and we were doing lots of those kind of things too. This image is representative of 5 years of my career, but I worked at the San Francisco International Airport.
So you designed the airplane?
No, I did not design it. I represented the owner. The San Francisco International Airport asked the company that I worked for to collaborate with them and to create a building owner side building information modeling program. So they were one of those forward-thinking building owners who really wanted to lean in and benefit from all of that data, all of that information and richness that the process brings about through design and construction. They were just starting a $7.5 billion capital investment program. It just goes in cycles. So once one part of the airport is finished, then they start with the other one. It's a never-ending process, just like the painting of the Golden Gate Bridge is. And the forward-thinking leaders of the airport thought that, okay, why don't we dedicate a chunk of that money? Mind you, this was just a drop in the bucket compared to the overall capital investment. to create a program where we can set up the requirements and the expectations. We can set up a team, and this team can work with all of the contributors, all of the designers and construction people, and really take in and harvest that richness of the information so that we can use that data and that information for the life of the building later on. And we did that, and I was happy and able to participate and lead that from a couple of different perspectives. So that was wonderful, and we learned a lot about stakeholder engagement. We learned a lot about how 200 people that are just the internal stakeholders have a lot of different opinions about what this program should give them, and we need to find a balance, and we need to make it efficient and successful. So it was a wonderful growing experience of my life and my career. And there was a Hungarian one too. So the Palace of Arts, this was very early in my career that I got to participate in Budapest, which is also a big complex. And we heavily used ArchiCAD and BIM way back when. And I still remember modeling and drawing one of the major stairs of the building. So whenever I'm in Budapest, I love to go there and go through that side door and look at that big stair that I only saw in the computer before when I was living in Budapest after finishing the university. I've also had a chance to work with key researchers and fantastic leaders in the industry for energy modeling that I mentioned to you, and other occupant well-being research related to buildings. This is all about how we can create environments and buildings that are really pleasant to the people that occupy it. Sustainable and green buildings are a big deal, not just because of being good to the environment, but also because of creating these wonderful spaces that we intuitively gravitate to as humans and we like as humans. So let's move on now and finally talk about what the future holds before we wrap up. There's a lot to do in terms of sustainability, a lot more to do. We are just scratching the surface, and frankly, sometimes I find myself very much impatient because of the pace that this is all being pushed forward. I think that we're just slowing down and going in the wrong direction as opposed to going in the right direction. But this is just my personal opinion about the whole thing. We could do much more and much more aggressively. But of course, there are lots of other factors in our world that dictate how sustainable architecture and sustainable buildings will come to fruition in the future. So I have great and high hopes about what this technology can bring and how it can help us to find that balance with nature around us and to create buildings that are not just good for us people, but also good for the environment too. The advancements in smart technologies are just amazing. So it changes just like everything else in technology super rapidly. And mind you, architecture and construction is really slow to change in general. Now that we're infusing technology into it, there's a significant speed improvement in that too. I mentioned to you that parametric and generative design, which is these concepts about putting together models that you can just use levers for to explore what it would look like with tiny little changes. Even though they've been around since the 60s, there's still a lot to do in terms of perforation in the industry and really making it benefit us. So generally speaking, I think that BIM will keep improving rapidly, and it will keep bringing about wonderful advancements, especially now that it seems like we've reached the tipping point where building owners and customers started to lean in heavily too. I sometimes feel like up until this point in my career, we're pushing this noodle and we're just pushing upstream. But now the building owners are here, so they can pull all of that with their power and their control. After all, we are designing the buildings based on their direction and their guidance. So I have high hopes that this will bring about wonderful changes and better advancements in the future. That's partly why I work with a building owner too.
Question about that. about the parametric design, and somebody is comparing that with the, the Toyota method, where at Toyota they love to ask the subsystem designers not just to design for a single point in a phase space, but to design with some trade-off curves, so then they can little bit push some of that those design points. Somebody is asking whether anything like that is being used with respect to parametric design in architecture.
Absolutely, absolutely. I had a chance to partake in a course at Stanford University, which has a group called SciFi, Center for Integrated Engineering. And they very much follow classic rules of lean design that stem from Toyota. And my fiance, not knowing each other, actually gave a course to the company that I worked for. And I just decided that I have too much to do, so I'm not going to attend that course. And we missed each other, but fortunately, we found ourselves later. So there's a deep infusion of lean concepts and lean design in this too, combined with the technology that we have available, and really benefiting from all of this world too. I haven't mentioned one aspect of green design and green buildings, which is now referred to as life cycle design. So what we do now in optimal cases is that we design buildings where the components are imagined how they will perform and how they will just change over their life cycle. So what I mean by this is that if I design this door, and if I choose this door, this sliding door for this conference room, then I have to take in consideration several different factors. I need to take in consideration the structural requirements. It needs a large opening with an overhead beam probably that can span that opening. I need to create an environment where the floor is smooth so that the rails can be embedded in the floor. I need to think about whether it should be metal or some other material, harmonizing with the rest of the environment. I need to take in consideration the cost. I need to take in consideration the sustainability factors, how sustainably the metal or the glass is produced that goes into this. And then finally, with the introduction of life cycle considerations, I also need to take into consideration that, well, 50 years from now, this was probably not part of the original building, I'm guessing, but 50 years from now, when this building or this part of the building will be demolished, is it going to be easy to disassemble this material and break it down to its components? And other companies like Apple consider these kind of things too these days, but it's very much present in buildings too. Yeah, and then just the last part of the futuristic opportunities that we have in front of us is of course, artificial intelligence and machine learning. People are already designing buildings just by a few sentences and well-articulated prompts. It's possible, and I think that it's going to bring about an entire revolution. We can start to use the computer for things that we can't even imagine. In fact, this very presentation was supported by ChatGPT. I asked it to be my presentation coach and really organize my thoughts about the subject and put it together. So I'm really optimistic and positive about this. So my final conclusions and takeaways are that be positive, look to the future, embrace change, be curious about advancements and innovation in architecture. Fortunately, I happen to be a practitioner of a profession that's half art, half engineering and science. So there's lots of resources that you can dig into, even if you're not an architect, that you can enjoy in this regard. And in fact, I put together at the end of the presentation that I guess Sully will distribute to everybody who wants it, a few examples. These are some resources that you can dig into as a follow-up, some reading material about green buildings, IoT, smart buildings, certifications, parametric and generative design. And I also want to promote one of my friends' organization, which is putting together a very interesting panel, upcoming panel. So you can even go there and hear about the latest innovators and startups in this sphere, in this space, pretty soon. So this is it. Thank you very much.
There's a question from the online audience. Question: UN SDG 4.A is a build and upgrade education facilities that are child disability and gender sensitive. Would you kindly tell us who are the leaders in such inclusive design, which firms specifically?
So this is a big subject. So I'll try to summarize it at the top. There are different variations of how inclusive design could work. There's the American Disabilities Act, which is governing all design in the United States, and this is also a similar subject of how inclusive design can support people in buildings. In even my own career, we had to follow rules of how spaces and doors and corridors need to be shaped. This is common ground. That's my short answer to that. That every architect needs to consider these kind of things today, and no exception. It's interesting that I delved recently into the practice and how this is all coming together from the legal perspective. There's no such thing where you have to do it because otherwise you will be punished, but rather if you don't do it, you can be sued afterwards for not following those rules in your design. And that's kind of a different enforcement mentality, which is interesting from the legal perspective too. So there's lots of good things in place. Yes.
I have a question. Once you have this building pretty much built up as a model, and then you have all these sensors around that collect data, were you thinking about start getting into a digital twin type of environment?
Yes. Yeah, digital twin is exactly, it didn't stem it, NASA came up with it as far as I hear it these days, but digital twin is a very popular subject right now in architecture and building information modeling. This is what's popularizing what I was just describing to you that came about from since like 87. It's more of it's a concept that's more consumable by non-architects and non-designers. Where you have this digital representation of the physical thing in the computer that you can use for simulations, you can use for modeling certain scenarios or future variants of the physical thing before you go about doing it. And you can also use it to monitor the building. So that example at NREL is very much of a digital twin because it's alive alongside with the physical building itself too. Yeah.
And it's fun to learn that the fifth dimension in the universe is money. So I actually have some questions. So you mentioned this net zero energy buildings, yes. And you mentioned that buildings can actually generate energy.
Yes.
And you mentioned that someone left the window open and then kind of created a higher temperature in the room. But I'm curious, like, what are the mechanisms of other processes, like just harvesting solar energy or geothermal energy or the gym?
There are fantastic ways of tapping into energy sources. Solar energy is a typical one, and lots of companies are popularizing it. There are solar panels and incentives, government supported incentives that help residential buildings or any other kind of buildings install these kind of systems these days. One of my favorite is geothermal energy, and there are lots of variations of that can be used for buildings these days. We in Hungary are blessed with a huge underground hot ocean that we can tap into, and that's why we have wonderful hot springs and recreational areas there because of that, and wonderful spas in Budapest too. But there are other types of geothermal energy which are more mundane, simpler. So imagine that 3 feet underground, the temperature stays constant pretty much through the whole year. This is a significant thing because of multiple factors when we consider a building. Foundations of buildings need to go down at least to that level because it will not freeze. And freezing would push up the building foundation otherwise if it's too shallow. So that's one of the reasons that's well known and have been practiced for a long time. But we can also dig in and create these pipe loops underground, and we can run water in a pretty shallow underground situation. And just that temperature difference could hugely contribute in the summer cooling the building and in the winter warming it up compared to the outside temperature.
There is somebody online who would like to ask it in voice. Go ahead, Aguda. Somebody would like to ask a question in voice. Go ahead. Go ahead, please.
Is it okay?
Yes.
Hi, Adam. Thank you, first of all, for leading the industry and for telling us non-specialists about these very exciting things. I recently was able to leave corporate. I left Google and I started my venture capital fund. And I also have a newborn. And so the reason I was asking you about inclusion, because I find the legal minimums that are designed into our buildings to be completely inadequate to me in 2023 as a working professional woman, from the sizes of bathrooms to, child safe office buildings. Like the whole design is actively hostile to me in a way that is paradigm wise unacceptable. So what you said about accessibility, it's very nice, but that legal minimum is so low and so without vision that what I was hoping to get out of the question is, are there any visionaries or crazies out there that are just building completely different, not so much parametrically or material wise different, but socially, yes, innovative, truly different setups?
Yeah, I'm sure that there are. I myself have not delved too deep into this subject, and I can empathize with you very much because, of course, the legal minimum is often not good enough for most of us, and there need to be some big changes and revolutions that change the overall legal minimum and really take it to the next level. That's a good question, and I should look into it myself of what those groups are that are leading in this space.
The reverse of it is there a culture of RFPs? Like if I raise some money for some design contest, for example, I have one of my close previous investors is sort of Harvard Design School, sort of, urban design head. Like, I think, is there a culture if we put out an RFP very specifically for some inclusive design that firms would consider?
Mm-hmm. So regarding this, I've had some personal experience, and I think the answer is yes. And the reason I get to say this is that when I had the chance to work along with the San Francisco International Airport and represent them as the building owners, I've learned a great deal about the value and what they bring to our community here in the Bay Area. One of it is that they're a large enough building owner that they can really influence the local smaller firms and local AECO industry altogether. So the way they were putting out the RFPs and the way they were putting out the expectations of what the technology that needs to be brought to the table, what the quality of the integration and the data richness that needs to be represented for those designs, arguably in quite a few years, because these are long programs, lifted up significantly the overall Bay Area standard of care in this regard. So I'm sure that if there's a well-crafted, well-organized, and publicized RFP that's targeting this awareness about inclusiveness, that could be done too.
Thank you. That was all wonderful, helpful. Thank you for the direction. Bye.
Sure. Thank you. Yes. Yeah.
I just had a question about the medical profession. What percentage of hospitals use, you were talking about the robots, this type of technology?
I cannot speak to that, unfortunately. I was just proud to mention it with the building that I was involved in. I think more and more. So the healthcare industry is quite advanced in its use of technologies. Let's just think about remote surgery robots and all sorts of other things. I don't know about the percentage, but I was able to participate in a very interesting conference. This was maybe 15 years ago because one of the principals of our company was not able to go. So the other principal said, "Do you want to go?" "Yeah, I want to go." So this was about all sorts of technologies in healthcare. And even back then, they were thinking about haptic feedback. So there were machines where you could hold a ball and you could push it forward and it simulated a rough surface and then you could feel it. And this was all headed up to and gearing up to these surgical robots that have to be super precise So there's lots of things that are super advanced in healthcare. I wouldn't be surprised if it's quite proliferated in this regard as well.
And the second question is, because I have the floor, have you designed your dream home?
In my head several times, and hopefully we will bring it together. Yes, yes,
I'd love to see it.
yes. It has to have a red roof. That's a critical requirement. Yes, because of my fiance's wishes.
Oh, okay. Not the door, the roof.
Yes.
I wanted to ask about innovative building materials like repasting concrete, repasting a lot of stuff that we are stuck in the mud, so to speak.
Yes.
And there are other things to use,
Yes.
but the regulations kind of don't let it, at least in the residential area,
Yes.
they don't let it do.
Yes. Yes.
So what are the new?
So much of our profession and the regulations around it are designed to protect people and occupants. And that's why some of it is really hard to change. But there are innovative materials, and there are some very interesting ones. Hungarians often contribute to coming up with new types of materials that are used in building and construction. There are translucent concrete materials, for example, that have the same characteristics of a real concrete, but it still partially lets light through. That's an interesting one. And all sorts of things where the durability or the strength of the material is just as much as steel or other heavy materials, but maybe the weight of the material is just a fraction. So that has a lot of implications in terms of the transportation cost, the cost of the building itself, the way it's constructed, and so on and so forth. But there's lots of other examples too, of course. Yes, there's a whole science around innovative materials and
Let's hope
building
so,
and
because we
construction.
need to improve. And my
Yeah.
other question is, now that we have this heat dome, and they are kind of hot.
Yeah.
So what are we going to do about cooling, especially because some of these areas, like the new developments, housing, whatever, they are full of concrete,
Yeah.
not a tree.
Yeah.
And
Yeah.
obviously is not designed to that heat.
Yeah. Yeah, I just saw a video just today that compared an urban setting. And mind you, design and architecture has a lot to do with the environment too, not just the building itself.
Mhm.
And it just put side by side an urban environment where there are no trees on the street. And there,
guess I saw
you
the
saw it
same.
too. And there are trees, and there's a difference of 10 degrees Celsius between the
Yes.
two, because trees not just shade but also evaporate water, and because of that, they have this amazing effect of natural cooling too. But
But the whole
going,
cooling system need to be overall.
yeah. So going back here, I still remember the first time I walked into the office building of one of my previous employers, which is called DPR Construction. It's an international company, and they're headquartered here in Redwood City. And their new San Francisco office building was one of the first net zero office buildings in San Francisco. And it's not just significant because of savings and because you could have the title and you could put that placard up there. But when I walked in, it was just a pleasant environment. It was just good to be there. It was not too light, too dim. The temperature was great. And it was very keen on not using artificial cooling too much. It was balancing it with other factors too. So that's why sustainable architecture and green buildings are not just because of this hippie aspect of trying to save the earth. I don't think it's a hippie aspect, but you know what I mean, exaggeratedly.
That's a good
But also about the human well-being
Yeah.
can be very much impacted positively by that. Yeah. Yes.
Thank you very much for the presentation. I think your slides were the most aesthetically pleasant slides I have seen in my life.
I had to represent my profession. Thank you. Thank you.
And my question would be about beauty.
Mhm.
So if you think about architecture, if we go back to Firenze, Florence, or Venice, even earlier, the ancient Greeks, the Pantheon, wherever, Acropolis, people still like to visit those buildings, take photos, upload it to wherever. And I remember I lived in London, UK for a couple of years, and every time I went to the South Bank Centre and the Queen Elizabeth Hall, similar to the Intercontinental Hall or the Marriott in Budapest, those buildings are really not so pleasant to look at least for me.
Yeah.
I think the idea to demolish, completely nuke them, because they are terrible. So I'm wondering, where is architecture going?
Yeah.
Did we reach the minimum,
hopefully,
in the universal history of humankind
Yeah.
in terms of ugliness? Or there is still more to come, because buildings that are thousands of years old where beam was not there and ArchiCAD, people somehow managed to design very pleasant and beautiful buildings.
Yeah. So, wow, lots to respond to this. Let's see. I think that we have not reached the bottom from your perspective. Not by far. There's lots of more ugly buildings to design and build, and it's all very personal. So I think one of the biggest challenges, even in a relationship with somebody, is with an architect, is that we have been taught through our career and our education to admire minimalism to the extreme. So if it was up to me, my ideal place would be a raw concrete building that's very square.
With a red roof.
With a red roof, because I love my fiance. Of course, I have to have the red roof. But having said that, there are wonderful modern buildings too. And when you go to New York, there are lots of examples of modern skyscrapers, train stations that look like amazing skeletons like dinosaurs that I'm sure will stand the test of time. In terms of those ancient examples, I admire going to Florence, and I love the Renaissance is my favorite era in terms of the history of architecture. So nothing will compete with that because it's a standalone thing. This is a difficult thing because it's a very personal observation. And trust me, when the Eiffel Tower was introduced, it was thought of, but I read about it. That's why you should trust me. I'm a Hungarian architect, so you should trust me. When it was introduced, half of the population, at least half of the population of France, thought that it's just an amazing eyesore that has to be demolished right away. Right away. They thought that they'd never seen anything as ugly as that before. So things change.
I appreciate that, and there's something novel. Half of the people will hate it just because it's novel.
Yeah.
But show me one person who thinks brutalism from the 50s is pretty. Really? Oh my God. They are doomed. I'm sorry.
So I have another question. I don't know the sense of beauty or not, but are you familiar some of the buildings in Dubai? It's just a matter of money. Because they are beautifully designed places, restaurants, and all. It's just because they throw money on it.
I know there are some examples, so some exceptions, let's say. I was fortunate enough to go to the top of Burj Khalifa, and I think that the Burj Khalifa is a wonderful architectural achievement. Very modern, so might not be pleasing to everybody.
I like it too.
Okay. But I have the same kind of assessment. This is also a personal assessment that there's a lot of money that's thrown around and flashed out because of representation. But this is very personal to me because when I finished university, the Technical University of Budapest, I wanted to go abroad for at least a year and a half somewhere. And I was thinking I would either want to go to the United States or I want to go to Dubai, because architecture, even especially for a young professional, was very much happening there. I wouldn't go there anymore. It's now I'm at a different stage of my life and my profession. Nevertheless, it's an exciting place and was an exciting place and has been and will be probably for quite some time in terms of new and different and just throwing it out there. There's the new development, if you heard about NEOM, which is this line in the desert. It's very controversial. There's lots of amazing videos, and if you contact me, I can send you some architectural critiques about NEOM too that I loved, which flat out says that, well, this is it's just a blasphemy. It's not going to work. You cannot just cut an artificial line in the middle of the desert, because even though it's the desert, it has its own ecosystem. So what happens to those animals and those living beings? And yeah, so there's lots of factors. Plus, it's a nice idea, but how it will actually work if it's clad by glass, and how it's going to heat up. Will you really achieve that comfortable inner courtyard feeling for such a long site? These are all very, very much questionable. But that region of the world is known for pushing the boundaries, and I really appreciate that.
Yeah, that's why I saw that. You might know some interesting design there or something that the O's are demanding.
Yeah. All right. Well,
Adam, so
yes.
let's assume that you know everything what you know today, but you would go back maybe like 60, 70 years in time. You would have only those tools available what people used to have. Like you would have like a big board, you would have like a ruler, whatever. And you would like to recreate one of your recent jobs. And you would like to recreate those parameters like energy efficiency, length of the cables, and the square foot, something like that. How much? I assume that is going to be worse because you do not have access to your
normal
tools, but you still have everything there, and you still have the construction capability. So you still can use the exact same materials, processes, but you just in a room. And so how much worse that going to be? And you can set up the parameters that you like, and I understand that it's going to be different and probably not even answerable. But just give me an example. What is the contribution of the IT in your
This is a really good question, and I had it in my notes to dig into how you can advocate or distribute this idea of introducing a new technology. I was at the forefront for many years in introducing the technology at the company, and half of the company, especially the senior leadership, was like very much against it. Like, we don't need this. We know how to build buildings and design buildings. There's a clear resistance to all of this, and some of those arguments are legit. Sometimes technology introduces more complexity than it solves problems if it's not introduced the right way. I think that the overall advancement is that, okay, so this is an outlandish answer, but I love sci-fi and I love the new Foundation TV series on Apple TV+, which represents a future, far in the future, of what architecture and constructs could look like. And I'm at awe when I look at that. I think it's artistically and wonderfully, beautifully done. But if you're an architect, you could also see that those structures would simply not be possible to do today. Not at all. So we are going to grow as a humankind in terms of technology and evolve, and it's going to be a slow churn and grind until we work out which pieces of technologies are really useful and not. In the long run, I believe that technology brings about wonderful advancements, and in the making of those advancements, there's a lot of victims too, unfortunately. So yeah, I'm a futurist and forward thinker, and I think that technology brings about things that I strive for to go to the future for. Yeah.
And what would be your selection or choice? Would you get the best IT support from this century and with a mediocre professional?
Mm-hmm.
Or would you go back and select the best architecture from the 1950s or whenever you want to back in time? But with no computer.
Yeah, thank you for the leading question. Obviously, the second one. Yes. Yeah, and I remember when you were kindly presenting to us, we've had this philosophical discussion too. Yeah, of how there's one thing to have tools available, but it also makes professionals lazy and not really use their mind and really push themselves to innovate. And they can just lean back because they're one of the few who can use it because they're younger or being taught at school or whatever that might be. And they just relax into that mediocrity versus, amazing professional tools at all because they applied themselves and they really try to do the best.
So I assume that there's going to be a point in time or a tilting point that is not true anymore. But I guess my question is that in your profession, is this point already here or not?
Well, my fiance will hate me for bringing this up again, but I think that we are reaching a tipping point with AI. This will change everything. I really think so. I really think that things are going to be so different that we can't even imagine it. And what this change will do is that it will shake out all of the riffraffs and the mediocres who are lazy and don't want to advance themselves. And they will be fine too because the new world hopefully can support them as well. But one of the favorite things that I have about this new large language model craziness is that it really comes down to asking the right questions. And that's a fundamentally human activity. For now, at least. For now, it still can be supported, but without asking the right questions, we can't really coexist with that or collaborate with that. So I think it will remain an even deeper human activity to march forward in the future and progress with technology because of that one thing. Yes.
In terms of you mentioned the Dubai and you mentioned Europe. In terms of the US and the architectural paradigm, assuming that every architecture has a set of filters and preconceptions and assumptions and trainings in terms of aesthetics and whatnot, if you could name 3 US buildings that represent the US architectural paradigm, I would be very grateful. Not necessarily favorite buildings, but the emblematic buildings or the ones that embody the US architecture.
I got to go back to the World Trade Center, the new World Trade Center site, not just the new World Trade Center itself, but the site itself, how it was arranged with the train station there, which is one of my favorite buildings.
I thought you were going to say the old FBI building.
Richard Mayer?
The old FBI building with the brutalist.
Yeah.
Was it Richard Mayer?
I think I don't want to butcher it. This is embarrassing. It should be, yes.
The sacral really white and it should be Mayer. But anyway,
there are others too. The Disney Concert Hall in LA, which is an iconic building. I don't like it at all. I think it's just too modern. It's too weird. So even I have my preferences in terms of this. I really love San Francisco. Is an interesting place. Other cities in the U.S. invested in inviting world-renowned architects, and we ourselves in the U.S. have had many world-renowned architects who produced amazing buildings. Here in San Francisco, lots of missed opportunities, as one of my mentors would say. But for example, the Young Museum is a wonderful building, in my opinion. And it's really well done, and it will be for the ages. They're just talking about how the building itself is aging, so that material that's used for cladding it is changing in color, going from brown to greenish as it goes through its life. There's a lot of, or the Academy of Sciences here in San Francisco too is one of my favorite buildings too.
But that's the one that has the top earth.
Yes. So I think that there's lots of things that we can see here in the U.S. too. But it's for an architect, it's wonderful to go anywhere and travel around the world and use the traveling as or the destinations as like driving points for traveling to visit these things. I still need to go to a lot of places, so it's almost like pilgrimage for me to go to certain sites. I still remember when I went to Istanbul for the first time and saw the Hagia Sophia. It was an awe-inspiring, almost spiritual experience for me, because I for years studied the building before in school and imagined it and saw it in my mind's eye, and then being there and experiencing the space just like it was intended to function was just amazing after all those years. But of course, that's not answering your question. But
Thank you very much.
All right. Well, thank you very much.
Thank you.
Thank you.
Thank you for coming. Did you ever make it to Dubai?